Hello, everyone. Welcome back to the Math Puzzle Crash Course. We've got a little example here, and if we're using algebra, we want to go through some word problems, show a methodology of how to go through these specifically, and this can really apply to any kind of word problem, but we're going to look at age-related word problems, which show up a lot online, a lot on the internet. So we want to go through and figure out a methodology to solve age type word problems using algebra. So an example of one of those would be this one, which got a video on here, but it's a father is 4 times the age of his daughter. In 20 years, he will be twice her age. How old in years are they now? Right, so that's an example of one of these word problems, and you may have seen these or run across these. And I'd say the first step to this really, and you want to break it down. I know sometimes these word problems can seem overwhelming, like where do you begin? But you really want to read these word problems carefully and look for the key information. It's the process of being able to extract that key information is key to the problem. Um, so, for example, you want to find out where in the word problem they're talking about the current age, any information related to the current age of the individuals, and look for the information regarding their ages in the past or the future. Sometimes they'll say, oh, 10 years ago, so and so was this many times older, or 20 years from now, so and so will be 7 times as old as so and so. That kind of thing. You want to look for that and note it. The second thing you really want to do is define a variable for the age of one of the people involved in the problem. Usually it'll be the current age of one of the individuals. Typically there's two people that are being compared. So you want to create a variable, and it could be any letter, A, B, C, D, X, Y, typical letter variables. So just define a variable for one of the ages. And then the other thing you want to do is you want to represent the ages of the other individuals in terms of that same variable that you used for the first person. So, for example, if you select the letter X to represent the age of the current age of one of the individuals, then you want to represent the age of that second individual in the same variable. So, for an example, like, today, if Susie is X years old, and today Mary is 3 times as old as Susie. Well, you could represent, Mary is 3x. So one would be X, one's 3x, that type of thing. That's what I'm talking about. Then the next step, but the fourth step here would be to set up the equations that represent the relationship between the individuals in the problem. And then, of course, the fifth step is solve the equations. But before you can do that, you need to make sure you understand those first four steps. And then the thing I always recommend is that you should verify your solution fits the word problem. Take the numbers that you come up with, go back to the word problem, and see if they fit. All right, so here's another example that we'll work through with this methodology. So this problem, it says Gertrude is currently 3 times as old as Hilda. 6 years ago, Gertrude was 4 times as old as Hilda. How old is Hilda now? So we're looking for Hilda's age today. We don't really know right now from that information, but if we remember those first steps, and we want to read the problem carefully, look for the current age info, define a variable for one of the people's ages, and usually it's going to be the current age of one of the individuals, and then represent the age of the other individual. So we'll step back here just a second and recall this. Gertrude is currently 3 times as old as Hilda. So that makes Hilda the younger of the two, right? Based on that. So I would say when we create this variable, we're going to make the variable equal to Hilda's age now. She's the younger of the two. So x will be the variable that we'll select, and we'll say that's Hilda's age today. And then we say Gertrude currently is 3 times as old as Hilda. So we could represent Gertrude's age now as 3x. So Hilda's x, Gertrude would be 3x. And so 6 years ago, that's pretty easy too, because Hilda would be x minus 6. You just subtract 6 from Hilda's current age. For Gertrude, her age 6 years ago would be 3x minus 6. Because it's 3x today, it would be 3x minus 6 6 years ago. All right, so the next thing, of course, is to set up the equations that represent the relationship between the individuals' ages. The key thing to extract out of the word problem was that 6 years ago, Gertrude was 4 times as old as Hilda. So if we wanted to make an equation out of that, and we'll look at that again. Remember, Gertrude's currently 3 times as old as Hilda. 6 years ago, Gertrude was 4 times as old as Hilda. How old is Hilda now? So 6 years ago, Gertrude was 4 times as old as Hilda. So the way to really approach that, you could say, well, if I took Hilda's age, she was the younger of the two, 6 years ago. If I took Hilda's age 6 years ago, multiply that by 4, that should equal Gertrude's age 6 years ago. Because we said 6 years ago Gertrude was 4 times as old as Hilda. So you just multiply Hilda's age by 4 from 6 years ago and set that equal to Gertrude's age 6 years ago. So this is a very important concept right here to understand to be able to solve this. And we know that Hilda's age 6 years ago was x minus 6. So we would multiply x minus 6 by 4 and set that equal to Gertrude's age 6 years ago, which is 3x minus 6. All right, so if we try to simplify that, 4 times x is 4x. 4 times minus 6 is minus 24. So 4x minus 24 equals 3x minus 6. Now we want to try to isolate x on one side of the equation and hopefully have constants on the other. One way we could go about that would be to add 3x, I'm sorry, subtract 3x from both sides of the equation. So 4x minus 3x minus 24 equals 3x minus 6. Well, if you subtract 3x minus 3x, if you take 3x minus 3x, that's 0. So you're just going to be left with minus 6 on the right side of the equation. Over here, 4x minus 3x leaves you with just the x, and then you have your minus 24. So this simplifies down to x minus 24 equals minus x. Then from there, you could add 24 on both sides of the equation. So x minus 24 plus 24 will just leave you with x. Minus 6 plus 24 is 18. So that leaves you with x equals 18, which would be Hilda's age today. Her age now would be 18 years old. We said Gertrude is 3 times as old as Hilda, so 3 times 18 is 54. So Gertrude would be 54. So, and you can go back and think about it, like go back 6 years ago. Well, 18 minus 6 is 12. So 6 years ago, Hilda would have been 12. Gertrude would have been 54 minus 6. She would have been 48. That would have been Gertrude's age 6 years ago. And we got to figure out if that matches the word problem. So 48 is definitely 4 times the value of 12. So 48 is 4 times as old as 12. So that fits the word problem. So, currently Gertrude would be 54. Hilda is 18. 6 years ago, Gertrude would have been 48 and Hilda would have been 12. So I hope this methodology makes sense, and you can really apply this on any of these types of problems, and it makes it a lot easier to solve. So hopefully this video has been helpful. If you've found any part of this helpful and you've stuck it out this long, Please consider give me a like, a share, subscribe to the channel if you'd like. I've got over 100 of these videos out there right now. Anything from order of operations to some algebra problems, um, and so on. I appreciate everybody who's lasted this long, and look forward to seeing everybody in the next video. Have a great day.